So you'll have to take 2.5 grams for each individual gummy bear. I'll say per gummy. Yes, right up here. 2.5 grams per gummy bear. And you just need to multiply it by how many gummy bears you have across there. If you're using skewers and just without any gummy candies on the end of there, just use 2.5 grams for the value that you will use for each of your skewers across there. But if you do have the gummy bears on the end, 2.5 grams. As long as we're using the same mass, we can still see the same ratio of difference regardless of what the mass is. But if you use gummy bears, they're 2.5 grams apiece. If you use something else, just Google the mass, the average mass of what it is, and you can use that mass for it. But once you have the speed of the wave that you calculated from frequency and period and wavelength, and then you also have the mass of the gummy bears that I just talked about for you to get from the total wave, you can then calculate the energy by just simply plugging it into a calculator. 1/2 times the mass, which is this value right here, times the velocity squared, which is this value right here that you already calculated in the previous version. So that's the data that you need. So the only thing you really need, because you should already have this value, the only thing that you really need is this period value right here, the period of the wave energy. So in order to do that, let's check the videos that we got for this. I made a couple of them from the ones from the setup that we had in class. I'm going to go ahead and bring those up. And these are the ones, is this all of them? Let me go to all of them. Is there more? Hold on. All photos. There we go. Oh, jeez, thought I lost one. Anyway, I have the 3 waves here that you can see. This first one right here is the low density wave. So this video that we have here, you can see me adding the energy to the side of it, and ultimately I'm gonna slow this down so you can kind of see the time on here. Well, here let's watch it go all the way through first. So we're watching the video. I'm adding the energy to the side of it. We're gonna flick the energy in a second, and you'll see it travel all the way down here. So you'll see it travel all the way down and all the way back. All the way down and all the way back. And I'll just play that again real quick so that you can kind of see where that came from. Well, oh my gosh, dude, this thing. There we go. Jeez. It's so hard to get to. So when you're looking at this and you're kind of watching this travel across here, what is going on? Well, technical difficulties here. Just let me. There we go. Jeez, was that so hard? So when you're watching this, you're adding the flick energy to it, and then you're gonna have it flick, go across, down, hit the other end, and then come back. And that's what you're looking for. The time it takes to flick, travel down the other end, and come back. And we're going to look at that for this one right here. For you guys who are using this data for your page there, add up the gummy bears for it. So if you're looking at this, video, pause it right here so that you can count up how many gummy bears you can see across that. Your Chromebook screen can probably get a bigger view than my screen can because I can't necessarily see all the way across there. But just count up the sticks and multiply it by 2 all the way across. Let's get this. There we go. So you have the flick energy go across there, and we can see it start right around there. So right around 8 seconds, it looks like. A little bit further. 8 seconds is about where that flick starts. It hits the other end. You can see right there, and then it's coming and bouncing back back to the original, and it hits back to the original spot right about there, which was about, boom, right there, 11 seconds. So 8 to 11 seconds, 8, 9, 10, 11. So it was about 3 seconds of time for that one. 3 seconds of time for that wave to travel across for the lowest density medium. So looking at the next one here, this is the medium density medium. This is still, this is 10 centimeter spacing, but more gummies now. I would pause it oh my gosh, if I could get this thing to work and not move all over the place, I would pause it if it allows me to do it. There we go. I would pause it right there to be able to count up the sticks, count up how many sticks there are across there, and you can multiply it by 2 to get the number of gummy bears that you need to get for your mass on there. But looking at this, you can see us add the flick of energy, and then right about 8 seconds right there, the flick goes through. You can see it travel down all the way to the other end. Keep your eye on the end there. And then it hits it, and then it comes all the way back. You can see it traveling through all the way back. And right about right there, I would say, is when it kind of hits back. And that was at 12 seconds. So from 8 to 12 seconds that time, so we added an extra second on there. So that was 4 seconds of time for the wave to travel across the medium density that we had. And then the last video that we have is the highest density particle. This would be like traveling through water. This would be the one with the highest amount of particles in the way here. And you can see us adding the energy to it, causing the flick to eventually happen right around, almost there. Jeez, come on. There we go. Right around there. So that's about 9 seconds it looked like. Let's double check that. No, wrong one. 9 seconds, right there, going across, traveling down. Keep your eye on it as it goes. This one's a little bit trickier to see because of how many particles are in the way. And then you can see it hit the end right about there. You can see it's so dense and so heavy that it's already sending other waves prior to hitting the other end. So now you have to watch it sort of come back and reverberate back through. And you can guesstimate to where it hit right about there, where that energy sort of bounced back through again, which put us right about, I think where that was like 14 seconds. Yeah, right about there is where it hits back again, so right about 14 seconds. So that one started 8 too? No, that one started at 9, I think. Started at 9 and went to 14, so that was about 5 seconds. So they increased by about 1 second all the way across with the particles that we added to it. And for this one, this is a good shot for it. Count up the number of sticks that you see across the screen there for the length of the wave, and this would be, and then you would multiply that by 3. So, to check those real quick. Those were the videos showing sort of the wave energy travel across. So let's see if we can sort of look to see what that looks like in the assignment there. So you had a period of wave energy. You have, if you're watching this video, you had 7 meters that you were using for your wavelength of each of the waves there. The period that we had the low density one travel across in 3 seconds, the medium density one traveled across in 4 seconds, and the highest density one traveled across in 5 seconds. And then when you're calculating the frequency of the wave, well, you're just using, the values that you got for the period here. So the frequency of the low density medium, if you're using this video's data, would be 1 divided by the period, which was 3 seconds. So it'd be 1 divided by 3 seconds. 1 divided by the period for that one would be 1 divided by 4 seconds, and then 1 divided by the period for that one would be 1 divided by the 5 seconds that you got. Ultimately, that would give you the value for the frequency for each of these waves. Once you have the frequency of the wave, you'll be able to calculate the wave speed. And the wave speed is simply the frequency that you just calculated right before it, multiplied by the wavelength. And the wavelength that you got for each one is going to be 7 meters. Because you got 7 meters value for each one of them that you're using there. And we're just measuring how much energy is used to make it travel across there. And then the mass of the gummy bears, let's see if we could just count those up real quick and try to guesstimate that. Those in photos. So the low density gummy bear, medium here. Oh, how do you pause? There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 25, 26, 27, 28. about 28 across there, so 28 times 2 for that. And we'll do that math in a second. For the medium density one, I'm going to go ahead and say this was 10 centimeter spacing. So if we're just doubling the amount of sticks that we had on it, that was instead of 28, it's going to be 56, because all we did was increase or decrease the centimeter spacing by 10 centimeters. So we doubled the amount of sticks on there. And then this one had if we had 28 across the first one and they were both 7 meters, and this one has, it's the same as 56, the same as the other one, but this one ultimately has 3 gummies across there. And then just to do the quick calculation for that, let's see here. Let me grab my calculator real quick. Calculator. There it is. Keep leaving this stuff all over the place. So just to calculate that real quick, our lowest density wave, low, medium, and high density. The low one had 28 skewers with 2 gummies each. The medium one had 56, because we just doubled the amount on it. And the high one also had 56 skewers. 2 gummies for